Hello, my name is Andrea Harkin and I am the GIS and Data Manager for Catchment Care. Today I'm going to talk a bit about how GIS technology and citizen science go hand in hand in the Catchment Care project. So communities are a very important part of catchment care, and engagement with local people is really vital to the project in some areas. To allow for this engagement and to promote awareness and the importance of water quality, project funding of up to €25,000 was available through the Community Incentive Scheme to support communities who are interested in looking after their local rivers and lakes. Volunteer groups, community groups, non-government organisations, schools and third-level education organisations, youth clubs and sports clubs, not-for-profit organisations and farming groups were all eligible to apply for funding for their local waterways. In 2019, there were a total of 29 applications made for funding under the Community Incentive Scheme. And the graphic here, you can see the breakdown by each catchment in the Catchment Care project. A total of 5 applications were received in the Arnie catchment, with 3 being finally approved. The Blackwater catchment received the largest number of applications at 15, with 10 being approved, and 9 applications were received in the River Finn catchment, with 3 finally approved. Out of the 29 applications, 16 in total were approved for funding in 2019, with a further 9 highlighted as having potential for 2020. So here now you can see the breakdown of the 2020 CIS applications. A total of 23 applications were received, 7 in the Arnie, and all were approved. Again, the largest amount of applications was received in our largest catchment, the Blackwater, and 12 were approved out of the 15. 1 CIS application was received in the River Finn catchment, and this was also approved. So out of a total of 23 applications, 20 met the correct criteria and were funded by Catchment Care. Extra funding was made available in 2020, such was the interest in the Community Incentive Scheme run by Catchment Care. Here now we can see a map of the Arnie catchment. It shows the distribution of community incentive schemes funded in 2019 and 2020, with the 2019 groups shown by a purple square and the 2020 groups, or phase 2, are shown as a green dot. There was a large variety of groups who applied, from heritage groups, boat clubs, manshed, community associations, and even a collaboration between the local angling club and the gun club. Again, we have a similar map for the Blackwater catchment. It's showing the spatial distribution of the Community Incentive Scheme groups throughout the catchment, with 2019 applicants with the purple dot and the 2020 applicants shown by a green dot. Again, there was a lot of variety in the groups: fisheries clubs and gun clubs, tidy towns groups and farmers groups. But the Community Incentive Scheme groups actually covered a wide range of sectors, from agriculture, community, leisure and activity, fisheries, to environmental and conservation groups, with funding for a wide range of activities such as interpretive panels, training, access to waterways, buildings, and physical works such as paths and jetties. Now, this slide shows the distribution of Community Incentive Scheme applications for the Finn catchment. And again, 2019 applicants are in purple, and the 2020 applicant is shown by the green dot. Again, a good dispersal throughout the catchment from Lough Finn downstream towards Balbafay and Stranraer. And again, a good variety in the groups, with the Fintown Anglers Club, Balbafay and Stranraer Integrated Community Company, the Finn Anti-Pollution Project, and Costa Sleeve to even Mullen in the Gaeltacht area up at Lough Finn. I've highlighted the Fin anti-pollution project, or the Fin app, on the map, as here I'm going to focus on the work they are currently carrying out in 4 areas along the River Fin. So here's just a little bit of information now about the Fin anti-pollution project. In 2019, Catchment Care funded the Fin app, which is a water quality monitoring programme where volunteers receive training and equipment to assess the water quality on the River Fin. This is a citizen science project where non-scientists are using water quality testing equipment and GIS at 4 locations along the River Fin. So before we go any further, I'll just talk a little bit about citizen science. So what is citizen science? It's defined as scientific research conducted by non-professionals or non-scientists. It's not a new development, but it's becoming more common as the technologies used are becoming more readily available and the people are becoming more aware of their environment and their surroundings. So this citizen science project aims to encourage curiosity about the river, give a greater understanding of their environment, and instill a sense of ownership in the River Fin and collect accurate water quality data. So our next technical term is GIS. So what is GIS? Well, GIS stands for Geographical Information Systems. It's a term a lot of people may be unfamiliar with, but it's really turning into an everyday software or a technology that people would use on a frequent basis. GIS is basically a file or a piece of information or data that has location information attached to it. It can be as simple as an area with a name, such as a townland that has a specific boundary. A good example that most people would understand and be familiar with is their air code. This is just a point at a specific location with address data attached to that specific point. Most people are used to maps on their smartphone to give directions or to find the nearest, say, petrol station, and is another example of an everyday GIS. A more technical description is that GIS is a framework to organise, communicate, and understand the science of our world. It is used to integrate many types of data, analyse spatial locations, and organise layers of information into visualizations such as maps. These can be printed maps or they can be interactive maps that are accessed over the internet. GIS can also query and compare data. It can reveal deeper insights into data such as patterns, relationships, and situations that may not be obvious from looking at a report or a spreadsheet. So the Fin app group were provided with equipment as part of the community incentive scheme. They were provided with a HASH HQ40D multimeter to test pH, conductivity, temperature, and dissolved oxygen in the water. They were given test kits for nitrates and phosphates, as well as provided with health and safety equipment, such as life jackets, wellies, and waders. Samsung tablets were also provided to the group for recording the results of their survey 123. So what is the survey 123? The survey 123 form is a simple form from ArcGIS. It is a form for gathering field data and it is used over the internet. With survey 123, I'm able to create a form asking specific questions, share with other people using a link or through an app. Then I can analyze the answers given through the form. So for the Fin app group, I created a form that asked questions about survey location. This was for the point where the group had taken their water sample, the water quality data, which were the results of the tests conducted using the multimeter, the river conditions at the time of the survey, such as river flow and the gradient at the sampling point. And there was also an opportunity for the surveyors to add in any comments or notes that they think is relevant as well as an image. So this is an example of the form now. As you can see, it's very similar to the traditional paper form that you would fill out with a pen. It starts off with some very general questions, such as the date, the name of the operator, and the location that the survey is taking place. There are 4 options to choose from here on the form, but only one can be selected. Now, the next part of the form is the map. Here, the surveyor can mark the location of the survey on a map. This can be done using the little Locate Me button here, or the surveyor can zoom in and out and move the map around till they're happy with the location. The second part then that you're looking at on the screen is river conditions at the time that the water sample was collected. Here the surveyor can fill in whether the gradient or the river flow was high, medium or low at the time the survey took place. The next stage in the form is the scientific stage, where the surveyor is asked to fill in the results from the multimeter. So temperature, pH, dissolved oxygen, conductivity, and the next 2 are nitrates and phosphates that can be filled in. And again, these are just filled in as a number. And the final stage of the form is where the surveyor can take a photo and upload it, and they can enter some notes if they feel that there's something they would like to comment on in the survey. Now the design, it was very important to get the design of the form correct. It had to be easy to use in the field, and it had to form a logical process. So for ease of use, the form was pre-populated with answers and options where possible. This cuts down on the amount of time spent entering data when in the field, as well as eliminating the possibility of errors and typos. So in this form, some of the fields are mandatory as they are deemed necessary for the survey. So the next stage then is the survey results. So I created an ArcGIS dashboard powered by Esri and hosted in the cloud to display the results. It's a GIS app that displays maps, statistics, and charts all in one location. So it's used to report on the data collected by the FinNet group. It shows the location of the sampling points, the results from the multimeter, and it holds all the location and survey information in one location. It's able to analyze, generate statistics, and create graphs and charts with interactivity representing the results. So I'll click on this link now, which will open up our dashboard, hopefully. To view this dashboard, you can also go to the Catchment Care website, where it's available in the map gallery. Now it's loading here now. So this is the FinApp survey results dashboard, and as you can see, it's split up into 3 different sections even. There's a map here at the top left. On the top right, we have 4 headline figures for each of the survey sites, and these are the number of surveys conducted at each site. And along the bottom here, we have an area containing charts representing the data collected. Now I have color-coded each site, so everything in blue, from the blue chart to the blue dots in the map to the blue text over here, represents the samples collected at Altona Paste, while everything in red is the Corlecky Burn, and so on. Purple is Drumbo, and the green on the map, the text, and the chart is the Kilty Vogue Bridge. So each of these areas has lots of interactivity associated. In the map area, when you click on a survey point, a little pop-up appears displaying the survey results. And I can scroll down here and it will give me all survey results that were conducted at these sites. Each survey location is then represented by stacked charts, graphically representing the data for each water quality test taken. Clicking on an arrow will scroll through the chart. You can scroll back. And it allows for a visual comparison at each site. There are also linkages between the charts and the map. So if I click on a value in a chart, it will zoom in and highlight that area in the map, as well as opening the pop-up to display the information about that specific site. So if I reset everything again now, I can go here to the map, and I have this little icon here, which actually expands the map out quite large. And as you can see now, it's maximized to the full window of the screen. So this allows me to interrogate the map in more detail. I can zoom in and zoom out. I can, again, click on a point and bring up the pop-up. There is a base map gallery here where I can switch my base map between imagery, mapping, orthophotography, various different maps. And again, I can close that and I can open a legend, which will tell me exactly what I'm looking at in my map. So I'll just minimize that again now, clicking this little button. And I will explore the charts. So again, I can click this little icon and it will maximize the chart for me. So I'm at Alt and Paste here, and I'm looking at the pH values that were taken using the multimeter. So as you can see, there are quite a few samples taken, and if I hover over a blue line representing the pH value, it gives me a little bit of more information. It tells me the date and it tells me the actual value of the pH taken at that day. So when I have the screen maximized like this, my other charts of all the other data collected at Alt and Paste appear as tabs below. So I'll just go through a couple of tabs now to show you that I'm using these charts to show a non-scientist the range of values that we would expect to find in each of the tests conducted by the survey team. So the first one is pH. And as you can see, there is a green background here behind the pH blue lines. So this is the normal range that we would expect to find pH values in. If I go onto the temperature graph, again, I can see the temperature in blue. And if I hover over it again, it gives me the range. So there on the 7th of April, the temperature was 8.9 degrees Celsius at Alt and Paste. The yellow background is the normal range for summer temperatures, while the blue here is the normal range for winter temperatures. So as you can see, during the winter, most of the temperatures fell within the normal winter range. The next chart I'm looking at now is dissolved oxygen. So as you can see here, the normal range and is above 6 milligrams per litre. That would be anything below that would be considered below the threshold for dissolved oxygen. And as you can see, all the values so far are well above the threshold. So again, this is an easy way using GIS that a non-scientist can interpret non-scientific data relatively easily and straightforward. So again, we're back to my presentation now. And that was a quick run through the FIN results dashboard. So as part of the FIN app community incentive scheme, they also erected interpretive panels along the FIN. They're both in Irish and English. So there's a link here to a little map tour of all the interpretive panels that were erected by CIS groups in the Catchment Care project. Or for more information and to explore more maps and more data about Catchment Care project, you can visit the map gallery on the Catchment Care website and have a look through all our maps, dashboards and story maps that are available there. Thanks for listening.